Okay, greetings. So, welcome to today's class. A quick recap of what we discussed yesterday. So, yesterday we started with the process of carburation, which is nothing but the process of formation of a combustible fuel air mixture and its subsequent introduction into the combustion chamber, right, to enable combustion. So, we looked at what were the factors that affected carburation and what type of mixtures are required for getting the best power output and the best fuel economy, right. So, and we also saw that a carburetor needs to allow for a certain regulation of the fuel air ratio depending on the amount by which the driver presses the throttle pedal, right. In a car or in a motorcycle we rotate the throttle hand mechanism, right. So, now the question becomes, how do we map the throttle opening to the fuel air ratio that is expected out of the device. So, this figure like shows a qualitative picture, right, of what is to be expected with respect to the throttle opening. So, as we can observe, on the horizontal axis we have throttle opening and the vertical axis we have the fuel air ratio. Let us say this is the stoichiometric fuel air ratio, the line, horizontal line indicated by the red dash line, and the solid line ABCD gives a qualitative picture of what is to be expected of the carburetor. So, the region A to B is what is called as the idling range, okay, and idling range, and of course, if you see low speed range, okay. So, or the initial acceleration range and so on, right. So, what is this idling range, So, essentially let us say suppose my car is parked at a signal. So, the vehicle is not moving, but the engine is idling, right. So, at some low RPM and we need to ensure that the combustion process is sustained in the engine so that I can pick up anytime I want. So, but as I go from idling and then like I start accelerating, we can see that the fuel air mixture becomes progressively leaner, right. It starts from a very rich mixture and then we can see that the mixture becomes progressively leaner, right, as we keep on pressing the throttle opening. See what happens typically when we drive a car from rest, we put it in first gear, we press the throttle opening gently, right. So, what we are doing is that from idling we are essentially accelerating, right. So, during the initial phase like we want a rich mixture which gets progressively leaner as we keep on pressing the throttle pedal, right. And let us say I go to a constant cruising speed, then we settle down into a leaner range where we get the best economy, okay. So, the region, what I will write it as a second region, which is B to C, is what is called as the cruising range, okay. So, a cruising range is where the vehicle is going at almost constant speeds, okay, and we want a lean mixture there, right. So, just to sustain the vehicle's motion, even when we look at the vehicle transmission, we will also look at what are the forces that the powertrain needs to overcome when the vehicle is being operated under various conditions, that is when it starts from rest, when it accelerates, when it is cruising and so on, okay. And as we keep on pressing the throttle pedal, and let us say we are cruising on a highway and suppose like I want to overtake a slower moving vehicle in front of me, what do? We go to the adjacent lane if free and then like we press the throttle even further, right. And then what I want is that like I want high power output from the engine such that even at high speeds I get enough acceleration to overtake the vehicle and go ahead. So, that is what is called as the power range. So, the third range goes from C to D is what is called as a power range. So, once again a progressively richer mixture is required as we go from C to D. So, during idling we need a rich mixture that progressively gets leaner with throttle opening. Okay. Okay. So, that is what we would want from the fuel delivery system or the carburation system. Now, when we are cruising, we want a lean mixture for best fuel economy. When we want to go to the power range, once again we require a rich mixture, so that like we are able to get the required energy to provide that necessary forces, right, to essentially accelerate the vehicle at high speeds. So, this is what one would want the carburation system to do, okay, in terms of fuel air ratio. Now, the question becomes, why do we want a rich mixture during idling? Okay, so, that is a question which we would naturally ask. So, what happens is the following, right. So, let us say we consider the simple schematic wherein like we have fuel and air mixed through a carburetor and provided to the intake manifold, right, and to the inlet intake valve or the inlet valve, right. Now, this is the throttle opening, okay, or the throttle valve which is controlled by the driver. Imagine a scenario where let us say we are driving a car and we are parked the car at a signal, the car is stationary at a signal. Okay. So, all of us would have removed our feet from the accelerator pedal. So, the throttle pedal displacement would be 0, but the throttle valve will have a small opening, so that some air is still flowing into the engine, but the opening will be the minimum possible, right. And like the combustion process has to be sustained, right, because we do not want the engine to switch off, right. Now, why do we require a rich mixture during this process? Imagine that in the fuel air mixture, an air is taken at atmospheric pressure and then like brought into the brought into the carburetor. Now, the throttle valve is completely the throttle displacement is minimum, is at 0, and the throttle opening is at its minimum possible value. Okay. So, and imagine a scenario where the piston is moving down. So, what can you say about the pressure here? The pressure in this downstream of the throttle, right, with the throttle valve being at its minimal opening, and when the piston is being pushed downwards, okay, this pressure is going to be small, right, is it not, because this throttle is closed, right. So, there is only a very small opening. So, the mass flow rate of the fuel and air is also limited because the throttle opening is small. Okay. So, the pressure here is going to fall down and the speed of the engine is also low. So, for each stroke there is more amount of time that is available. So, typically what happens is that when this pressure is small and when the exhaust stroke happens for a previous cycle and the exhaust gases are being pushed out, please remember the exhaust gases will be at higher pressure and no process is perfect, right. So, and typically there may be a small amount of overlap between the time at which the exhaust valve is closing and the inlet valve is opening. So, during idling this time interval is also a little bit higher because the speed of the engine is also low. So, what may happen, this exhaust gas pressure is high, this intake manifold pressure is low. So, what can happen? This exhaust gases can also get into the intake manifold and there can be significant exhaust gas dilution. So, what do I mean by exhaust gas dilution? Exhaust gas dilution means the exhaust gas mixes with a fresh charge, right. So, this means that exhaust gases mix with the fresh charge. Charge or fuel air mixture, okay. Charge means fuel air mixture, right. So, obviously this is going to affect the combustion of the fresh charge, right. So, because for combustion we need fuel, we need oxygen and we need a mechanism for initiating the combustion process. But if I mix exhaust gases, the amount of fresh air that is available will also reduce in proportion and the chances of the fuel not getting burned properly also may increase. So, the engine may shut down, right. So, in order to prevent that or even in order to overcome that, we have a rich fuel air mixture in the expectation that although all the fuel may not combust, at least a significant part of it will still combust and sustain the combustion process. So, idling is not beneficial because in idling we are going to have significant unburned fuel in the exhaust, okay. But in order to sustain the combustion process due to exhaust gas dilution, like we require a rich mixture, okay, to sustain the combustion process due to exhaust gas dilution. So, the primary reason for behind the requirement of a rich mixture during idling is exhaust gas dilution, okay. So, we require a rich mixture to sustain combustion during idling due to exhaust gas dilution, or in other words like the dilution of the fresh charge due to exhaust gases mixing with them, okay. So, that is what is called exhaust gas dilution. Is it clear? So, that is the those are the three regions: the idling range, the cruising range and the power range, okay. And we have a qualitative map with respect to the mixture expectations as far as throttle opening is concerned. Now, having seen the requirements, we will also see how these are actually realized in practice, okay. We will look at various fuel introduction systems now, okay, and then we will analyze one in detail, okay. So, that is going to be the flow of information. So, if we look at the actual fuel introduction systems, please recall that there are two key requirements, right. In addition to other requirements, broadly there are two key requirements. One is atomization of fuel. As we already discussed, atomization means like we want the fuel droplets to be broken down into finer particles, right. So, and then we want those fuel particles to be vaporized, right. The liquid fuel must be changed into its gaseous states and mixed with air. So, those are two key requirements, right, of any fuel introduction system. So, in atomization, as we have already observed, the injected fuel is broken down into smaller droplets. This increases the total surface area of the fuel exposed to air, right, to aid vaporization. Okay, so that is the bottom line, right. So you break it down into smaller droplets, smaller what to say fuel particles, so that like we increase the surface area of the fuel particles and that can be vaporized, right. So now the question becomes, like what are the different devices, like that are typically used to achieve these requirements. The first one, although in general we call any device that does this carburation as a carburetor, but like we will look at different what to say generic names given to these devices. Okay, the first one is what is called as a traditional carburetor or a conventional carburetor. Okay, so what is this device? Let us discuss what this does. So a traditional carburetor, like nowadays used in maybe some two-wheelers and so on, right, is the following. So what happens is this. So we have what is called as a float chamber. Okay, you can visualize what is called as a float chamber, and we have fuel coming from the fuel tank, and this is a float arrangement to ensure that a sufficient amount of fuel level is always maintained in the float chamber. Okay, so we will discuss this carburetor in more detail and analyze them. And what happens is that this fuel is taken out and then like brought to what is called as a fuel discharge nozzle, whose tip is in the throat section of a venturi. So what is a venturi? A venturi is a smooth reduction in the cross sectional area of a flow chamber, right. So that is a venturi. So what is the throat of a venturi? It is the place at which the cross sectional area is the minimum, right. So this fuel discharge nozzle tip is placed at the throat of the venturi. Now what happens is the following. Let us say air is being sucked in, like to the carburetor, and air flows. When air flows through the venturi, at the throat the pressure drops, right, and the kinetic energy of the air increases. So the speed of air increases. So due to a pressure difference between this fuel level, right, at the top and the throat, the fuel starts flowing, okay, and it gets mixed with the air because the air is moving at certain speed. It essentially takes the fuel, atomizes it, and then like takes it downstream. So the throttle valve is downstream of the venturi and the fuel air mixture goes out of the carburetor. Okay, so that is how the carburetor functions. We will shortly look at a detailed discussion on carburetor. Okay, we will discuss it in more detail and also analyze that. Okay, so these are the main attributes of a typical carburetor. Okay, so the main points are that, so the air is drawn in through a venturi, okay, resulting in a drop in pressure and increase in speed. Okay, so that is what happens. So the fuel particles come out of the discharge nozzle and mixes with air. Okay, so that is what happens. So what are the main advantages? The main advantage is that like it is simple in construction and design, okay, and no external fuel pressurization is required. Okay, so the process happens by itself. You do not need a separate pressurization device like in other mechanisms that we will shortly see to pressurize the fuel and then introduce it. Okay, it happens by itself. Okay, so the flow of fuel happens on its own due to this venturi action. So the pressures typically in a carburetor are of the order of 1/10 of bars. Okay, So that is the range of pressure difference, okay, the operating pressure difference. That means that the pressure difference between the discharge nozzle tip and the flow chamber surface is of the order of 1/10 of a bar, okay. I am only talking about orders because the actual numbers vary from design to design, right. So this is of the order of 1/10 of bar, right. So no fuel pressurization, so it is simple, but there are a few limitations. So compared to other designs, the atomization and vaporization are going to be relatively poor, because anyway the higher the pressure difference, like better is the atomization. Here the pressure difference is the lowest, so relatively like this is going to result in poor atomization and vaporization, and it is challenging to control over a wide range of operating conditions, okay. Like so, because we will see that like when we do analysis of a simple carburetor, so it is going to be a challenge to accurately control it, okay, to over a wide range of operating conditions, which is possible in other mechanisms. We will come to other mechanisms shortly, okay. So that is the simple carburetor, okay. So now what is the next option that is available? The next option that is available is what is called as port injection, okay. So what is port injection, like, so we will look at it, okay. So the first one is a simple carburetor, I hope it is clear, okay. So now let us come and look at what is called as port injection. So what happens in a port injector or a port injection system? So in this system, what happens is that we have the piston and the cylinder, and we see that this is the intake path, right, manifold path, right. So it comes from the intake manifold. Let us say we consider a multi-cylinder engine or even a single cylinder engine, like the air has to come from the intake system, okay. The air starts flowing through the intake system and starts coming here. Now just before the inlet valve, a fuel injector essentially sprays fuel at the appropriate time, okay. So that is what is called as a port injection system. So here the fuel is not mixed with air before the intake system, okay, as in a simple carburetor, right. In a carburetor we have a carburetor where the fuel air mixture is prepared and then given to the intake manifold, right. So here the injection of the fuel takes place after the throttle, okay. The throttle will control the amount of air which will come through into the intake system, and the fuel injector sprays fuel at the appropriate time instant into this intake area, okay, just upstream of the intake valve, okay. So that is what is called as a port injection system, okay. And the pressure range, the operating pressure range of this port injection is of the order of 10 power 0 bars, okay, like typically ones of bars, okay. So you can see that it is one order of magnitude more than the simple carburetor. So higher the pressures, what will happen? The injection pressure, the atomization of the fuel will be better, right, and it will mix better with air, and then like atomization and vaporization will become more efficient, okay. So the main attributes of this system are that the fuel is introduced close to the intake valve with low pressurization. Okay. So, there in a simple carburetor there is no external pressurization itself. So, here it is a low pressurization. Okay. So, this enables better atomization. So, typically the most common configuration is essentially using one injector, one fuel injector of course, per cylinder in a multi-cylinder engine. So, this system is what is called as a multi-point fuel injection system. Okay. So, that is what is abbreviated as MPFI. So, if you look at if you encounter what is called as an MPFI engine, that is what they use, right. If you have a 4-cylinder engine, you have 4 such injectors which inject fuel just upstream of the intake valve, okay, in a multi-cylinder engine. So, that is what is called as an MPFI system, okay, injection system. Okay. So, what are the advantages of this port injection? So, of course, improved atomization due to higher pressure and vaporization. Okay. Compared with carburetor, and it also has what is called as, compared to a carburetor, reduced wall wetting. So, what is wall wetting? You know, like the fuel which is introduced can just settle on the walls of the intake pipe, right, or the intake system, right, and that is going to be wasted, right, is it not correct? So, when you spray the fuel with some pressure, we are going to reduce it, okay, when compared with the simple carburetor. So, we are talking with respect to the carburetor, okay. So, it results in reduced wall wetting, but of course, there are still some limitations, okay. So, still fuel films are created along the inlet pathway, okay. Although it is, the fuel is introduced close to the intake wall, still fuel films are caused in the inlet pathway, okay. So, that is still a limitation, okay, of a port injection system.